Hello friends. So today we are going to see and learn more about the topic electric motor, DC electric motor class 10 CBSC. So what all are important parts that as a student you must know when you are learning about electric motor? First of all, its principle, then its construction, working, and lastly its uses. So let us begin with the principle. On what principle is it based on? It is based on the principle that if an electric carrying conductor is placed in a magnetic field, it experiences a force. I repeat, when a current carrying conductor is placed in a magnetic field, it experiences a force. Based on this principle, an electric motor is constructed. In your syllabus, you have DC motor. And the main function of this DC motor is to convert electrical energy into mechanical energy. यानी कोई भी आप मोटर को करंट सप्लाई करेंगे और आपको मिलेगा क्या? तो आपको एक मैकेनिकल एनर्जी में वो कन्वर्ट किया, जैसे कि कोई मोशन, कोई मूवमेंट, ऐसा कुछ आपको रिजल्ट मिलेगा. तो अल्टीमेटली इलेक्ट्रिक मोटर is going to convert electrical energy to mechanical energy based on a simple principle. And how will you come to know the direction of that force that it is going to experience in the magnetic field? You will know it by using Fleming's left hand rule. We will see that once we will start with the working. Construction. Once the principle is known to you, what is its exactly on what principle it is based, what work it is going to do, we should know what are its parts. Now, simple basic parts we will discuss. First of all, it should have a magnetic field. Magnetic field कैसे मिलेगा? तो एक magnet होगा. There would be a permanent magnet placed here. Very strong magnet. Reality में electromagnet होता है, but we will talk about a simple structure. So we will say there is a magnet, strong magnet, north pole, south pole. In that magnetic field, we are going to place a coil. In reality, in real motors, there are many coils, many turns to that coil. But for simplicity, we will consider only one single coil here. Naming A, B, C, D. चलो एक मिनट रुको बच्चे, इसको नाम हम अच्छे से देते हैं. We will initially say that A, B, C, D. This is how the coil is aligned in the magnetic field. What is that coil attached to? It is attached to a split ring. एक ring है, उसको divide कर दिया two halves में. That is called as a split ring. One single ring divided into two parts. Split ring. I have given it a name P and Q. I'll draw a split ring, a bigger, this is how it's going to look like. Okay. This is how it looks like. So P, one section, Q, another section. That is mounted on an axle. The axle which is actually going to move and going to create a mechanical effect. So axle is there, split rings are there, then there are brushes, X and Y. Now a question arises, brushes क्या काम करने वाले? Brushes are going to be the connectors. They are going to be there for fixed connection. X and Y, when the axle will rotate, will not move from its place, will remain there. When the axle is moving along with the split rings, the brushes will remain there and they will give it a contact, electrical contact. These brushes are connected to a battery and ultimately to a key. Key will act as a switch. I'm sure you have understood what are the different parts of an electric motor. We are done with principle, we are done with construction. Now comes the main part, working. How does a electric motor, DC electric motor works? Let us see that. Now, first of all, setup हो गया. Now the key is on. Key is on, the current starts flowing. When it starts flowing, you know the direction. It always flows from positive end to negative end. So initially the direction of current in this circuit would be from positive end to X, then to A, then to B, then C, then D, and back to Y, and ultimately to the negative terminal of the battery. See the direction of current. Positive end to X, A, B, C, D, Y, and then negative terminal. So I can say that the current is flowing like this. Very good. If it is like this, at these sections A, B and C, D, I am going to apply Fleming's left hand rule to know in which direction that part of the coil is going to move. Let us see that. Let us see AB section first. We know the magnetic field is always from north to south. North to south. Current is shown by the second finger, magnetic field by the first finger, and thumb is going to show me the direction of force. So let us see. From north to south, magnetic field. Current from A to B. The force on AB section of the coil will be inwards. See again, children. Magnetic field, current, force would be inward. That means this part of the coil will move inwards of the board. Imagine on the board, if it is square, it will move inwards. What will happen to this section CD then? Again apply Fleming's left hand rule. Magnetic field, current, force, outwards. So on CD, the force would be outwards. That means the coil will move like this, and ultimately it will complete one rotation, and this portion of the coil will come this side and AB will go that side. But just look at the portion of the split ring to which this coil is connected. Just look at this. D is connected to Q and A is connected to P. When they will complete one rotation, if this coil is going to complete one rotation, this is going to move. And what is going to happen? Initially X was connected to P and Y was connected to Q. Now after one rotation, X would be connected to, because it is going to rotate, right? So what's going to happen? X will be now connected to Q and Y will be connected to P, and this coil has turned. So it is going to become like this: A, B, C, D. Are you getting it, children? Okay. Now the coil has completed one rotation, and now AB side has gone to the left hand side and DC has come to the right hand side. Now look at this. Still there is a battery, and look at that battery. It is still having the same polarity, but now how will the current flow? The current will flow from X to Q. Just 1 minute, huh, beta? X to Q. Sorry, not to Q. X to D, D to C, to B, to A, to Y. Let me draw it here. X to D, D to C, to B, to A, to Y. Now let me see how the force would act on the side DC. Again applying Fleming's left hand rule. Magnetic field, current, and now CD will move inwards. This section will go inwards. And what will happen to section AB? It will move outwards. Again it will complete one rotation and will reach back to the same position where X would be connected to X would be connected to P, and then A, B, C, D, Y. again the same rotation, and ultimately this axle is going to rotate in one particular direction, and then we will get our result, and the result is ultimately to convert electrical energy to mechanical energy. Any doubts? If there are doubts, you can discuss them later on. You can share your doubts on a personal link. Till now, principle, construction, working. 3 things we have completed, 3 targets. Lastly, uses. Use कहाँ होता है? इसके use तो होना चाहिए. बनाया है पूरा इतना बड़ा DC motor, उसका use तो होना चाहिए. So, honestly speaking, people say that it is there in the fan, it is there in the mixer, grinder. Actually, there the AC motors are there. DC motors are used in exhaust fans, the table fans, the toys in which there is some kind of circular motion, scientific projects that you people make in the schools, also in the water pumps. Okay, also in the water pumps it is there. और बहुत ही इंटरेस्टिंग जो मुझे लगा इंटरेस्टिंग वो था कि ट्रैम्स, जो ट्रैम्स को मूव कराने के लिए, जो ट्रेन्स होती है ना जो रोड पे चलती हैं, ट्रैम कहते हैं जिसे, उसे रन कराने के लिए ह्यूज डीसी मोटर्स आर यूज्ड. So yes, DC motors are useful and it is a very important part in your syllabus. So children, go through the video again and I'm sure your doubts are clear. Chalo, bye bye. See ya.